Alright, so here are the notes for section 2.6. We're going to do it a little bit differently than your book does. Your book asks you to make tables for all of these, and it takes a really long time. After you make the tables, then you have to plot all the points, connect them so that you can see what the graph looks like. And you have to do that for quite a few different graphs before patterns start to emerge. So we're going to do this all with our graphing calculators. It will allow us to see the patterns much more quickly than the way your book teaches it. And at this point, you have made enough XY tables, picking values for X, plugging them in, solving for Y, that, I'm hoping that you can do that and it's not a big deal. I want you to find the patterns and find them quickly here. Okay? So what you're going to do here is follow along the video notes, sketch the graphs, and make notes of the translations. If you've printed these, you've got, each of those things that you need. You're going to have a chance to practice with the graphing calculators while you're in class doing your classwork. Okay? If you want to try to do it with the Desmos calculator as we're going, you can always pause the video, try it on there. That gives you a chance to work with that calculator a little bit. Totally free, app you download at home. But as far as the TI-83s, you'll see mine on the screen and you'll get to work with those in class. So the first function that we're going to graph is, and I'm going to slide it over here, y equals x squared. So on my graphing calculator, I'm going to type in, let me slide this over, on the y equals screen, y equals x squared, and go ahead and graph it. Okay, and remember, if your screen doesn't come up centered like this, you can press zoom and 6, that's the standard graph window, so that it will recenter it and your graph will look like mine. Okay? Here's what it should look like. If you want to plot specific points, remember you can look at the table by pressing second and graph, because table is written in blue above it. And here are specific points you can plot. You'll need some negatives and some positives. But instead of being super specific here, we're just going to sketch it in. Okay, I can see that it starts down here at 0, 0, and it goes up this way and this way. Okay, every x squared graph that you work with, okay, every x squared equation, the graph is going to resemble this. Okay, x squared is called a quadratic, and the graph is a parabola. Now, because every x squared graph is going to resemble this one is said to be your parent function or the parent graph. Okay, this is your parent function, this is the parent graph. So what we're going to do in the next couple of examples here is we're going to add some additional numbers to my parent equation or my parent function. Notice, in the second one here, all I've done is put a +2 after my parent function. Well, I want to graph that and show you what it looks like, and then we'll talk about what it did to the graph. Okay, so I am going to leave my parent graph on the screen in blue, and I'm going down to the y sub 2, and now I'm going to graph x squared plus 2. And my new graph will be graphed in red. So here we go. Okay, you see the parent function. Now the red one is my new graph. That is the new function. And if you'll take a look, the parent function, if you just take and slide it up 2 units, you end up with the red graph. So let's come over here and sketch it. So when I have y equals x squared plus 2, instead of starting at 0, 0, it starts here. That is our vertex, and it is the same shape, and it's going the same direction. So what happened to this graph to get this one? Basically I want to know, what did this plus 2 do to it? Well, it shifted up 2 units. So now, let's take a look at the next problem. All right, for this one, I've got my parent function, and then I've got a minus 3 after it. What do you think that minus 3 is going to do to it? And you should base this, hypothesis on what happened here when there was a plus 2. When there was a plus 2, the graph shifted up 2. If there's a minus 3, what do you think is going to happen to it? I think it is going to shift down 3. So let's come back over here to my graphing calculator and test it. Okay, so I'm going to once again leave the parent function, but I'm going to change my y sub 2 to a minus 3 and press graph. Okay, so there's the parent function, and there is the new graph. And yes, it did move that vertex point. Every single point on the whole graph shifted down 3 units. So let's come over here and let's sketch it in. 1, 2, 3 units down. Okay. So that graph, or that equation, is shifted down 3 units from what my parent function looked like. That's what this minus 3 did. Now, we're going to look at this one. It's a little bit different. I've got some parentheses this time where I didn't have those in the past. So let's grab our graphing calculator and we'll type it in. Okay, so once again, I'm going to leave my parent function for y sub 1, and I'm going to change my y sub 2. So let's clear it out, and let's type parenthesis x plus 1, end parentheses, and then squared. Okay. Once you've got that typed in, oops, I need to hit graph. So here's my parent function. And what happened to the vertex of that one? It is shifted to the left 1. Here's what it looks like. That vertex has moved here, and it still looks like the same graph, it's just been moved over. So the translation is shifted left 1 unit. All right, I got too much on my screen. Let me make this one a little bit smaller. There we go. Okay, so when I had a plus 1 in the parentheses, it shifted to the left, and it went left 1 unit. So now, what do you think this minus 4 in the parentheses is going to do? Okay, if the stuff that came after my square moved it up and down, this one moved it left, what do you think this is going to do? I think it's going to shift it to the right 4 units. So let me pull my calculator back up. I'm going to change my second one to be -4 and then graph it. There's the parent function. And here's my new function. And yes, it is shifted to the right 4 units. So let me move mine out of the way a little bit here. So 1, 2, 3, 4. And it is the same basic graph. It looks the same. And my translation for that one, it is shifted right 4 units. Okay, and these are just sketches. They're not perfect. It doesn't have to be at this point. This is good enough. So now let's take a look at the one here at the bottom. This one, I don't have any parentheses and I don't have anything added to it. All I've got here is a negative that's out in front. So let's see what that's going to do. Let's go back to my y equals. Go down and clear out your y sub 2. And we're going to type in negative. Okay, and remember, you want to hit the negative button. Because if you don't hit the negative button, you're going to get an error message. Kind of like this one. So if I hit subtract x squared and I try to graph it, well, maybe it's going to work. Oh, no, there it is. There's my syntax error. Okay, I get this question all the time. Why am I getting this error? I typed it in right. And remember, you can always go down to go to, highlight that one, and press enter, and it will blink and show you what's wrong with it. Remember, if you want a negative x squared, your negative key is next to the decimal. So now that I've made that correction, now let's graph it. So there's my parent function. Here is the new graph. So what did that negative in front of the parent graph do to it? It just flipped it upside down. Oops. Let me get my calculator back up here, or at least this part. Okay. So what happened here is I'm still having a vertex at 0, 0, but it looks like this. So, while we might just say that it flipped, technically, here's what you're supposed to write. It has been reflected across the x-axis. Okay. But as long as you know it's been flipped and you can sketch it correctly, I'm good with that. In Math Excel, to answer some of the questions, you're going to need to know the word reflected. That just means you flipped it upside down. All right, 2 more graphs we're going to look at. All right, so now I have y equals 3x squared. So no parentheses, nothing added after. It's not a negative here, so it's not flipped upside down. I need to know what that 3 does to it. So let's graph it and see. So go back to your y equals, leave the parent function in there, and I'm going to replace my negative with a 3. So I have 3x squared, and graph it. So there's the parent function. There is my new function. So it still has its vertex at 0, 0, but it looks skinnier. So here I've sketched mine in, and notice I just sketched it so it looks skinnier. Again, it's not perfect. So my translation, I'm going to write over here that it looks skinny. But here is your correct terminology. It says that it is stretched. Oops, I forgot my R. It is stretched by a factor of 3. And this is the technical vocabulary you're supposed to use. If I'm asking you to sketch something, you need to know that it looks skinny and sketch it skinny. But Math Excel is going to want you to use the correct vocabulary and just say that this 3 makes it stretched by a factor of 3. So now I had this number that was bigger in front, or it's bigger than a 1 coefficient. And remember, on our parent function, let me find my paper. On our parent function, our coefficient, there wasn't a number written there, so it's understood to be a 1. So that coefficient is a 1. When my coefficient was bigger, it was stretched nice and tall, and it was a skinny graph. Okay? So now, let's see what happens when I put the 1/4 in front of it. Okay, you may want to go ahead and kind of decide in your mind what you think it's going to be, and then see if that's what really happens. So let's go down, and I'm going to clear out this whole thing just because it's easier. 1/4x squared. And let's graph it. There's the parent function. There's the new function. So when I had that fraction that was between 0 and 1, it kind of made it wider looking, and there's a real word for that, but we're going to get there in a second. Okay, so let me move this out of the way. We'll sketch this one. Again, the vertex is still at 0, 0, but we're going to make it nice and wide looking. Okay. So your correct vocabulary for this is that it is compressed by a factor of 1/4. And when I say it's compressed, that's like you've got something on top of it that is pushing down on it that forces the sides out wide. Okay? It's not compressed this way, it's compressed from the top down. Okay? So this is what you need to know if you're trying to sketch the graph. This is the vocabulary you need to use for Math Excel, and most standardized tests will also use this vocabulary. So now, let's take a look at my chart here at the bottom. I'll get my graph stuff out of the way for a minute. Here we're going to talk about translations for any function. Okay? If I have y equals f of x, this just represents my parent function. That's all. So now, when I put a number inside, that's just like this one. When I put it inside, remember that either went left or it went right. Okay, when it was a positive in here, I went to the left, which seems backwards. When it was a negative, I went to the right, which also seems backwards. So let's take a look. This is a minus 3, so that's going to have to go left or right, and we want to do the opposite thing. So that means it's going to shift right 3. But now what is this plus 2 that comes after going to do to it? Well, x squared was my parent function here. When I had something that came after the parent function, this shifted it either up or down. And it did exactly what it looks like it's going to do. If it's a negative 3, it shifted it down. When it was a plus 2, it shifted it up. So this is a plus 2 that comes after the parent function, so that is going to make it also shift up 2. And this is for any function. It doesn't have to be a parabola. It can be anything. And we're going to talk more about this on the next page. All right, so here, for the next one, I'm going to highlight my parent function. My parent function is here. I need to know what this number in front does and what this one does. So I know that negative. What is that negative that's out in front of your parent function going to do? It is going to reflect it across the x-axis. The 1/3, and I'm not worried about it being a negative 1/3, the 1/3 is a fraction that's between 0 and 1. And remember, for this one, this fraction was between 0 and 1. It made it look wider. So the translation is that it is compressed by a factor of 1/3, and then this minus 1 that comes after. Remember, if it comes after your parent function like this, that's going to be your up or down. So it's going to be shifted down 1. Okay. And we're going to get lots of practice with this stuff. I've got a whole activity you're going to do in a little while. All right, so now we're actually going to take a look at that vocabulary that we've been talking about a little bit throughout that chart. So now, reflected, and this is reflected across the x-axis. That just means that it has been flipped. Okay? Compressed, and this is compressed from the top. That makes it look wide. Stretched, remember that is stretched tall. That is stretched tall from the top. And that looks skinny. Your horizontal shift, that is left or right. And that is when you have something that is inside the parentheses. And what you're going to do is you're going to do the opposite of that sign. Your vertical shift, remember that's when it shifts up or down. And that comes after the parent function. And you're going to do exactly the same as what the sign of that number is. So now, let's go back and add, well, no, we'll do it down here. General form of a quadratic. So if you have this incorporates everything that was in those graphs we just did. If there was a number in front, okay, A represents that number. If A is positive, it's going to open up. Which means it's going to look like a U shape. If A is negative, it is going to flip upside down and open down. A couple of other things about the A value. If A is greater than 1, then it is going to be stretched. It's going to look tall and skinny. Okay. And your book doesn't just say A is bigger than 1, it says the absolute value of A. And they do that because when I'm deciding this, I don't look at whether A is positive or negative. I cover that up and I just look at the A itself, which is technically the absolute value. The other thing about the A is it says that if that absolute value is between 0 and 1, which means it is a fraction, that's when your graph is going to be compressed, or it's going to look wide. All right, so now for the H and the K. Your H value shifts left or right. And you're going to do the opposite. And when I say do the opposite, that means the opposite of the sign. Okay, so normally when something is minus, you think shift it to the left. No, we're going to do the opposite. We're going to shift it to the right. And when it's positive, normally you think I'm going to shift it to the right. Well, no, you do the opposite. You're going to shift it left. The last thing we need here is your K value. And K will shift it, or shifts the graph. I can't spell and talk at the same time today. Let's try this again, because that was almost not good if I had left that. Yeah, and I know some of you are giggling because you're teenagers. It shifts up or down. And this time you're going to do the same as the sign. So if it's a positive K, you're going to shift up. If it's a negative K, you're going to shift down. All right, so that is it for section 2.6. We will have plenty of practice in class.